Okay, our objective is to continue talking about probability end of next week. Today we're going to review what we've done so far, and then Tuesday we're going to talk about permutations and combinations. I'm also trying to decide, I would like to teach you guys compound events, but I'm not sure if I'm going to do that yet or not. So that's a very interesting probability topic that you usually don't learn until Algebra 1, but I think I might teach it to you guys this year. So it's interesting. So again, I'm guessing the end of next week, but I'll let you know for sure, depending on how you guys do with permutations and combinations. Annalise? If I teach it to you. I'll just make a new test if that's the case, because I have never taught permutations and combinations or compound events to the 6th grade class. It's more of an algebra topic, so. Yeah, but I'm going to teach you the formulas. N factorial over n minus r factorial. I'm going to teach you the whole thing, not just like the basic idea of it. Okay? All right, so let's go over our warm-up. You guys finished this really quickly, so I'm guessing this was pretty easy. Okay, Mary, can you tell us what you got for number 1 for the warm-up? Wait, say that again? 17 million. No, your numbers are a little backwards. Emma H? No, unless my numbers are backwards. Adam? No. Then my numbers are backwards. Sean? Okay. All right. 2 of my numbers are backwards. Yep, sorry guys. Sorry, you're right. I don't know why 2 of my numbers were backwards. Sorry, you're good. That's very bizarre. Or I don't know. Okay, number 2. I'll go over that one if you guys need me to. Doug, number 2? Good, 24. Emma M, number 3. Good. Zach, did you get to number 4? Okay. Number 4, Donatus. Good. Matt, number 5. Man, you guys are good at this. Justin, number 6. Good. Okay. Questions? I can go over number 1 since I completely confused you guys on that. Questions on any of those? No? Sean? Wow. Yes. Wow, I'm impressed. You guys like this? Just easy? See? Okay. We are. I'm going to teach you guys more of it next week because you're doing so well with it. You'll like it. Okay, but even if it's difficult, it's my job to teach it to you so it seems easy. Do you know what I'm saying? So it's okay. I can still teach you hard stuff. All right. Yeah, exactly. Let's go to, whoops, homework solutions, page 91. Okay, homework solutions, page 91. Now, some of you guys were confused on 1, 2, and 3, so let's go. I warned you about that yesterday, so let's go over it, and then if we need to have a discussion about 1, 2, and 3, letter B, we can do that. So, Charles, number 1, what did you get for A and B? Good job. Number 2, Sean, A and B. No? Okay, no, stop guessing. Anyone get B for number 2? Doug? Nope. Charles? Yep. Number 3, Matt, A and B. Okay. No. Justin? Nope. Anyone besides Charles know the part B? Annalise, what'd you get? Yep. Okay, so there's the answers for 1, 2, and 3. I'll come back to them if you need me to. Okay. Yeah. Okay, hold on. Shh. Let's go over the rest, then I'll come back to it. Okay, so it jumps to number 7. Emma M, number 7. Good, 720. Donatus, number 8. Good job. Alyssa, number 9. Perfect. Emma H, number 10. Good job. Annalise, number 11. Yep. No, it's 6,720. I promise on that one. Annalise, number 11. Good. Sean, number 12. Good job. Doug, number 13. Good. Okay. Justin, 14. Perfect. Matt, number 15. Man, you guys did awesome on that. Very good job. Okay, before we flip over, let me go over the B part of 1, 2, and 3. Now, ideally, if I wasn't 5 minutes late with you yesterday, I wanted to do one of those with you. So I apologize if you were frustrated with those. So here's what they meant for B, okay? So 1B said, for the word tack, letter B is, how many ways are there to arrange 2 letters of the word tack? So 2 letters, not 4, just 2 of them. If you were to put one letter down, how many options do we have for one of the letters of the word tack, Mary? Good. We have 4 options. So for letter B, it's 4 times. Let's say we put the first letter here. The second letter we put down. How many spots are there to put it? Doug? Good. So let's say we put it here. There were still 3 spots that we could have put it in. So 4 times 3, there are 12 ways to arrange 2 of the letters of the word tack. And you can put them anywhere. Any different arrangement for those 2, there's 12 ways to rearrange those 2 letters. So that's what it meant. There's 4 spots, but there's 2 ways to arrange it. Annalise? No. Nope, because there's still 4 letters of the word. They're just asking you, from that word, how many ways are there to arrange any 2 of the letters? Okay, I'll get to that. Hold on. Anyone else on 1, 2, and 3? Do you guys want me to do another one, or do you get that? You get it? You guys are very smart. Okay, you sure? Yes, I can do 3. The second part of it, Mary, or both parts? Okay, so in 3, the word is gamer. So 1, 2, 3, 4, 5. So there's 5 letters. They still ask you for B. How many ways are there to arrange 2 of the letters of the word gamer? Yeah, the first time you put a letter down, there's 5 spots. Let's say we put it here, okay? 5 times. The second time you put a letter down, there's 4 spots. So let's say we keep it here. It doesn't matter where you put it. There were 4 options for that second letter. Because it's only 2 of the letters, not 5 of the letters. The first one was 5 times 4 times 3 times 2 times 1. The second one is 5 times 4. Charles. Good, what'd you do? What's your reasoning behind that, though? Okay. To me, that doesn't make sense, but okay. What'd you say? You got 15? Yeah. Three plus 2 plus 1 is 6, yeah. 5 plus 4, 9, 10, 11, 12, 13, 14, 15. You're right. You get 15 if you do it your way you're right. 4 plus 3, 7, 8, 9, 10. Yeah, and you get 10 for number 1. So that doesn't work. Charles. Okay, so don't do it that way. Not only does it not make sense to me, but it doesn't work. Okay? Hey, Charles, do you understand the way I explained it? Okay. Okay, just making sure. Okay, Annalise, what did you say, number 12? Okay, all you do is type into your calculator 15 factorial divided by 14 factorial. Or you can use mental math. I know this is going to drive you guys crazy, but watch. 15 factorial. I'm not. Hey, Adam, hold on. No. Over 14 factorial. Okay, Annalise, did you put in 15 factorial divided by 14 factorial on your calculator? All in one step? Hold on. No. Yeah, hold on. Yeah. Hey. Annalise, did you put them in? You got 15? Okay, look at the smartboard for a second. Do you see what I started to write out? Look what happens. All this cancels with all this. So you could also like use mental math, like, or common sense, whatever you want to call it. Okay. Did anyone do it this way? Or did you guys put it in your calculator? Calculator, okay. Does everyone understand it the long way by looking at it this way? I always just think about those ones in my head like that. Okay. Okay, anyone else on this assignment before we go to the other one? Sure? Wow, you guys did very well. Okay, page 92, you just had 6 to 13. Make sure I'm on the right page this time. Okay, so this was just the back of it. So number 6, Zach, what'd you get? Back of page 92. No. You should have an actual answer written out. Like 9 million something. No, much more than that. You're looking at the one for realization, right? Okay, much more than that. Emma H., what'd you get? Good. Okay, number 7, Doug. Good job. So let me just go to number 6 for a second. Zach, make sure you understand why it should be 11 factorial over 2 factorial times 2 factorial. There's 11 letters in the word realization, and then there's 2 repeats. So there's 2 repeats. You have 2 factorial times 2 factorial on the bottom. Does that make sense or no? Okay. Sean? No, because remember, 4 factorial is 24. 2 factorial times 2 factorial is 4. Yep, 7 is 10 factorial over 2 factorial, 2 factorial, 2 factorial. Do not multiply factorials together unless you multiply them all out. What I mean by that is 2 factorial is 2 times 1, 2 times 1, 2, you know what I mean? Don't say 2 factorial times 2 factorial is 4 factorial. That is not true at all. Doug, what are you doing? Someone at the door. All right. That happens. Okay, is everyone clear on 6 and 7? All right, Mary, number 8. Great job. Adam, number 9. Good. Can someone besides Adam tell me how to do that? Who can explain that? Sean, how do you do that one? Mm-hmm. Good. That's a problem where when you type in 18 factorial divided by 20 factorial, you hit math, enter, and it reduces it and changes it to 1 over 380 for you. Okay, Donatus? No. Well, it does say to, well, but it also says don't leave your answer as a decimal. Okay, let's change it to a fraction. What's wrong, Matt? Okay. No. All right, number 10. Donatus, what'd you get for 10? Good. 0 factorial is something we didn't talk much about. Well, actually, we didn't even talk about yesterday. Anytime you have 0 factorial, it's 1. I'll get into this more with you next week when I teach you permutations and combinations. Okay, 0 factorial is always 1. Okay, there's one way to arrange 0 objects. Okay, there's no way. That's kind of the reason behind it. I will talk more about that next week when we get into permutations and combinations. Emma? Yes, it's just like exponents. Very similar to that. All right, number 11, Charles. Good, 1 over 120. Justin, number 12. Perfect. And number 13, Sean. Yep. Good. What did he do wrong? Good. He added them instead of multiplying. All right. Any questions on page 92? Doug? Okay. Number 11? Okay. So the probability that lions is going to be spelled correctly when you hold posters up, okay, favorable is 1 because there's one way to spell lions correctly. Over, there's 5 factorial ways to arrange all the letters in the word lions. So 1 over 5 factorial. Does that help or no? Sure? If they're asking you what the probability of doing something correctly is in regards to spelling words, then yes. Okay? Matt? Yeah, I made this whole thing. Can you tell because I went to Penn State? This is why I used Penn State and Lions, yes. Annalise? Go ahead. Correct. We're going to talk more about that today. Multiplication counting principle versus factorial. Okay. Can anyone answer that a little bit right now? How do you know when to use the multiplication counting principle versus factorial? Alyssa? Awesome. Anyone want to add to that? That's perfect. When they ask you how many ways there are to arrange something, use factorial, always. When they ask you how many different combinations or how many different outcomes there are, or even possibilities, that's when you use multiplication counting principle. That's perfect. Mary? Typically, they'll ask you for how many arrangements there are. There are sometimes that the wording's not going to be exactly what I'm saying, but majority of the time it's going to ask you for the arrangements. But yes, sometimes they could say how many combinations are there. In the context of the problem, you guys will get really good at realizing when to use what probability method, okay? All right, either get your notebook or some kind of scrap paper. So your notebook, back of a package is some kind of scrap paper. Doesn't have to be something nice. And I want everyone to write down the word baseball. Make you do what? I'm getting there. I'm getting there. Okay. Okay, quiet. On your scrap paper, I want you to tell me how many ways there are to arrange the letters in the word baseball. I want everyone to tell me how many ways there are to arrange the letters in the word baseball. Jeremy?
47.
No. Take your time. What? You got it? No? Guys, be careful. When you get your answer, just put your pencil down. We're going to talk through it. We're going to talk through it in a second. When you get it, just put your pencil down. We're going to talk through it together. I don't want you guys to make mistakes on something like this. Jeremy, Donatus, what are you doing? Okay, Matt, what did you get? Adam, what'd you get? Zach, what'd you get? Annalise, what'd you get? Sean, what did you get? Charles, what'd you get? Emma H, what'd you get? Doug, how did you set up the problem? Okay, when you put it in your calculator, you have to have parentheses. So if you did not put parentheses, that's why you didn't get the right answer. 8 factorial divided by all in parentheses, 2 factorial times 2 factorial times 2 factorial, you get 5,040 ways to arrange the letters in the word baseball. Charles. Yeah, you showed me your way yesterday. That works. Zach? Well, you took off the 8 and multiplied 7 factorial? Right. You're fine. Yeah, that's smart. So you kind of did mental math and then multiplied. Okay, any other questions on the word baseball? You guys are doing great with that. Okay, one more word, the word Mississippi. How many ways are there to arrange the letters in the word Mississippi? Go for it. Good job. Oh, how'd you know math would give you a headache on a Friday, huh? Oh, it won't be on the test, I promise. MISSISSIPPI. Okay. Be careful on this one. Yep. Keep going. You gotta do more than that, though. Figure out how many repeats there are. Awesome. Good job. Yep. Perfect. We gotta keep going. But yes. No. That top number's not right. Perfect. Good job. Good job. Good job. We're getting there. Yeah. Nope. Figure out how many repeats there are. Careful. Well, it's not just this. I'm adding more probability next week. Good. Sorry for scratching you. Good. Yeah, you just got to find the answer. Yep, you got it. No, we're not doing that. All right, so Mississippi, we have 11 factorial over 4 factorial times 4 factorial times 2 factorial. Alyssa, what should we get? Good. Questions on Mississippi, Sean? Good. Not right now. Now listen, hold on. If you guys want to come up with any crazy words and bring them into me, we'll do them in class. Well, not now. Not now because I have other things I want to do right now. But if you have any other crazy words, bring them in and we'll do some fun ones, okay? All right. On your paper, next thing I want you to do is find the odds in favor of rolling a 3 on a number cube. So I want you to write down for the next problem. This is kind of like a practice test. What are the odds in favor, just write it down, of rolling a 3 on a number cube? We need to talk through this. Some of you are still confused on the difference between odds and regular probability. So we are going to talk through this. So just write the answer down. I'm not going to come around right now. All right, Emma M., can you explain this to us? Good. Not 1 over 6. What you said is right, but your number is wrong. What's the unfavorable? Yeah. So never use total with odds. There's one number 3 on a number cube. There's 5 numbers that are not number 3s. So there's one number 3, there's 5 that are not. Is everyone okay on that? Okay, second one. What are the odds against landing on red on my great spinner that I made? What are the odds against landing on red? Write down what you think the answer is. I'm going to have someone else explain it. Odds against landing on red. Okay, Donatus, how do you do this one? Tell me how to do it, though. Tell us, I should say. Unfave over fave. Tell me the fraction again. Good. There's 3 colors that are not red. Over, there's 1 color that is red. So 3 over 1, or 3 to 1. Easy? Emma? No, 3 to 1, because it's odds. Okay, let me jump to... Okay, I want you to simplify this. Next problem, simplify this. Annalise. No solve. You can't solve, there's not an equal sign. Simplify. Simplify this. 10 factorial over 12 factorial. So simplify, do not keep it as a decimal, keep it as a fraction. 10 factorial over 12 factorial. No. Try that again. Did you type it into your calculator? 10 factorial. Don't forget, guys, math prob number 4. Oh, divided by. And then 12 factorial. And then math, enter. Hit math, enter. There you go. I just typed something in wrong. All right. Mary, what'd you get? Good. Any questions on how we get 1 over 132? Annalise. Cannot do that. That's completely different than 10 factorial over 12 factorial. Remember, it's not 10 over 12. It's 10 factorial over 12 factorial. Annalise, all you're doing is typing that into your calculator like the homework, and then hit math, enter. Okay, convert it to a fraction. Any questions on that one? Okay, one more question. Okay, ignore all these. I'm going to pull this screen down. Ignore all these other ones. I want to go to the last one. It's just very hard to see. Okay, I'm going to read this to you. Okay, number 7. On a history exam, you are asked to list 5 historical events in the order in which they occurred. You guess the order of the events at random. What is the probability that you choose the correct order? Five historical events that you have to list in order on a test. You guessed the order, you didn't study for some reason. So we want to find the probability that you're going to guess the order correctly. When you think you know it, put your hand up. Is that honest? You know it? Okay, put your hand up. Jeremy, do you know it? Okay, why wasn't your hand up? Okay, 1 over 120. Okay, there's one way to get the correct order. Over, there's 5 factorial ways to list the historical events in order. So 1 over 5 factorial is 1 over 120. You use probability for this, which is favorable over total, because they simply asked you, what is the probability that you're going to get the correct order? So it has to be favorable over total. Annalise? No, because they asked you, what is the probability that you choose the correct order? So if they're asking you for probability, it has to be favorable over total. Okay, any other questions on that? Charles? Okay, hold that thought. All right, I want you guys to put your name on what I'm passing out, and then I need to explain this to you. So put your name on this. Nothing new today. Like I said, I kind of wanted to take a little break today and practice this to make sure everyone's on the same page. And then Tuesday, we're going to move on. Okay, we have about 15 minutes. Is anyone, well, Briar might not be at school, never mind. Okay, put your name on what's being passed back. Okay, the first thing I want you to do is when you get to it, cross off number 23. So when you get to it, cross off the number 23. Very first thing I want you to do, cross off the number 23. Okay, number 3, make sure you keep it as a fraction. Number 3, make sure you keep it as a fraction. And then the last thing that I have up there is the spinner on page 2, which I'll leave up here, all class. If you can't see the spinner on next to numbers 11 through 15, here it is, just in case your copy didn't turn out so well. The spinner next to numbers 11 through 15 is right here. So in case you can't see it very well on yours, here it is. What? Right, that's why I put this up here, just in case. Okay, I want you to get started on this. This is due Tuesday. Okay, I want you to work on your own for now. Just get started on your own. Okay, if you have a question, put your hand up, let me know. Doug? You mean Tuesday? Yeah, we could. Yeah. Okay, for now I want you to work on this, and then Tuesday we're going to move on to the next probability topic.